When selecting surge suppressors for large residential projects, several factors come into play. Let's consider the offerings from Square D, Eaton Cutler-Hammer, and Intermatic, evaluating their features and benefits to make an informed decision. Square D's home logic whole-house surge arrest stands out with its impressive 100,000 amp surge capacity. This high capacity enables it to absorb and divert a substantial amount of electrical energy, offering robust protection against power surges and lightning strikes. Additionally, it incorporates responsible lockout technology, enhancing safety and preventing potential hazards. A significant advantage is the lifetime warranty, providing long-term peace of mind and demonstrating the manufacturer's confidence in the product's durability and reliability. Eaton Cutler-Hammer's CHSB Whole Home Surge Protector offers a surge capacity of 60,000 amps, providing a considerable level of protection against voltage spikes. It includes a light-emitting diode fault indicator, allowing for easy monitoring of the suppressor's status and quick identification of any issues. The 10-year warranty provides assurance of its quality and performance over a significant period. Intermatic's IG2040-1 whole-house surge guard features an 85,000 amp surge capacity, positioning it competitively in terms of protection capability. It incorporates a diagnostics display, offering detailed information about the suppressor's operation and potential issues. The 5-year warranty provides a reasonable level of coverage. When evaluating surge suppressors, surge capacity is a critical factor to consider. A higher surge capacity indicates the suppressor's ability to absorb and divert more electrical energy, providing better protection against larger surges. Response time is another important aspect. A faster response time ensures that the suppressor can react quickly to sudden voltage spikes, minimizing the risk of damage to sensitive electronics. The warranty offered by the manufacturer reflects their confidence in the product's quality and durability. A longer warranty provides greater peace of mind and protection for the investment. Additional features, such as lockout protection, diagnostic displays, and remote monitoring capabilities, can enhance the suppressor's functionality and user experience. Considering the information provided, Square D's home logic whole-house surge arrest appears to be the best overall choice for large residential projects. Its very high surge capacity, responsible lockout technology, and lifetime warranty offer superior protection and long-term value. To maximize protection, it is recommended to install surge suppressors at the electrical panel to protect the entire home. Consider installing additional surge suppressors in areas with sensitive electronics, such as home offices or entertainment systems, to provide an extra layer of protection. Utilize surge protectors to safeguard individual devices such as televisions, computers, and appliances. Regularly inspect surge suppressors and replace them as needed to ensure continued effectiveness. Surge suppressors, also known as surge protection devices or SPD, are designed to protect electrical devices from voltage spikes in alternating current circuits. A voltage spike is a transient event typically lasting only a few microseconds that can reach thousands of volts. These spikes can be caused by lightning strikes, power outages, or even the switching on and off of appliances. Surge suppressors work by diverting the excess voltage to ground, preventing it from reaching and damaging connected devices. There are different types of surge suppressors available, each designed for specific applications. Whole-house surge suppressors are installed at the main electrical panel and protect the entire home from surges entering through the electrical service. Point-of-view surge suppressors are plugged into individual outlets and protect devices connected to that outlet. These are commonly used for computers, televisions, and other sensitive electronics. When selecting a surge suppressor, it is important to consider its surge capacity, measured in amps. This indicates the maximum amount of current that the suppressor can safely divert. A higher surge capacity provides better protection against larger surges. The voltage protection rating, or volts let through, is another important specification. This indicates the maximum voltage that the suppressor will allow to pass through to connected devices. A lower voltage protection rating provides better protection. The response time of the surge suppressor is also a critical factor. A faster response time ensures that the suppressor can react quickly to voltage spikes. Look for suppressors with a response time of less than 1 nanosecond. Surge suppressors typically use metal oxide varistors, or MOVs, to divert excess voltage. An MOV is a semiconductor device that changes its resistance depending on the voltage applied to it. Under normal conditions, the MOV has a high resistance, preventing current from flowing through it. When a voltage spike occurs, the MOV resistance drops dramatically, allowing the excess voltage to flow to ground. Surge suppressors also include a fuse or circuit breaker to protect against sustained overvoltages. If the voltage remains too high for too long, the fuse or circuit breaker will trip, disconnecting the suppressor from the circuit and preventing it from overheating. It's important to note that surge suppressors have a limited lifespan. Each time they divert a surge, their capacity is reduced slightly. Over time, they will eventually wear out and need to be replaced. Some surge suppressors have an indicator light that shows when they have reached the end of their lifespan. Regularly inspect surge suppressors to ensure that they are still functioning properly. If a surge suppressor has been subjected to a large surge, it may need to be replaced even if the indicator light is still on. Consider installing surge suppressors on all incoming electrical lines, including phone lines and cable lines. Surges can enter a home through these lines as well. When installing a whole house surge suppressor, it is important to have it installed by a qualified electrician. The electrician will ensure that the suppressor is properly grounded and connected to the electrical panel. Point-of-use surge suppressors are easy to install. Simply plug them into an outlet and connect the devices that you want to protect. Use surge protectors with Underwriters Laboratories or UL listing. This indicates that the protector has been tested and meets safety standards. Avoid using power strips that do not have surge protection. These strips simply provide additional outlets and do not protect against voltage spikes. Choose surge protectors that have a high clamping voltage. Clamping voltage is the voltage level at which the surge protector starts diverting excess voltage. A lower clamping voltage provides better protection. Note that no surge suppressor can protect against a direct lightning strike. If you live in an area that is prone to lightning strikes, consider installing a lightning rod system to protect your home. Also, unplug sensitive electronic devices during thunderstorms to prevent damage from lightning strikes. Check with your insurance company to see if they offer discounts for homes that have surge protection. Surge protection can help to reduce the risk of damage to electronic devices and appliances, potentially saving you money on repairs or replacements. Beyond the specific models mentioned, several other manufacturers offer reputable surge suppression solutions. These include companies like Leviton, Siemens, and AB. When researching these alternatives, pay close attention to the specifications discussed earlier, such as surge capacity, voltage protection rating, response time, and warranty. Consider the specific needs of the electrical system you're protecting. For example, in areas with frequent lightning strikes, a higher surge capacity may be necessary. In locations with sensitive electronic equipment, a lower voltage protection rating may be preferred. It's also important to ensure that the surge suppressor is compatible with the electrical system. Check the voltage and amperage ratings of the suppressor to ensure that they match the electrical service. Many surge suppressors offer advanced features such as remote monitoring, which allows you to monitor the status of the suppressor from a remote location. This can be useful for large residential projects where it may be difficult to physically inspect surge suppressors on a regular basis. Some surge suppressors also have audible alarms that sound when a surge event occurs. This can alert you to potential problems with the electrical system. When selecting a surge suppressor, consider the environment in which it will be installed. If the suppressor will be exposed to moisture or extreme temperatures, choose a model that is designed for those conditions. Ensure that the suppressor is properly grounded. Grounding is essential for surge protection. A poorly grounded suppressor will not be able to effectively divert excess voltage. Check the grounding system regularly to ensure that it is in good condition. Consider using a whole house surge suppressor in conjunction with point-of-use surge suppressors. This provides multiple layers of protection. The whole house suppressor protects against surges entering the home through the electrical service, while the point of view suppressors protect individual devices from surges generated within the home. Regularly test surge suppressors to ensure that they are still functioning properly. Some surge suppressors have a test button that you can press to test the suppressor. Others require the use of a multimeter. If a surge suppressor fails the test, it should be replaced immediately. Document all surge protection devices installed, including their location, model number, and installation date. This information will be helpful for maintenance and replacement purposes. Share information about surge protection with all residents of the home. Make sure they understand the importance of surge protection and how to use surge suppressors properly. Encourage residents to report any electrical problems immediately. Even small electrical problems can be a sign of a larger issue that could lead to a surge. Consider installing a surge protection system as part of a larger home automation system. This can allow you to monitor the status of the surge protectors remotely and receive alerts when a surge event occurs. A surge protection system can also be integrated with other home automation features, such as lighting and security. Work with a qualified electrician to design and install a surge protection system that meets the specific needs of the project. The electrician can assess the electrical system and recommend the appropriate surge protection devices. The electrician can also ensure that the surge protection system is properly installed and grounded. Remember that surge protection is an ongoing process. It is important to regularly inspect and maintain surge protection devices to ensure that they are functioning properly. It is also important to upgrade surge protection devices as needed to keep up with changes in technology and electrical codes. Keeping in mind the latest revisions to the National Electrical Code or NEC, specifically Article 230.8 addresses surge protection requirements for dwelling units. It mandates that surge protection devices or SPD must be installed on all dwelling units. NEC Section 230.8 states that surge protection must be installed. The SPD must be either integral to the service equipment or located immediately adjacent thereto. In summary, the NEC requires surge protection for dwelling units to enhance safety and protect electrical systems from damage caused by voltage surges. The requirements may vary based on local interpretations and amendments, so consulting with a qualified electrician or local authority is essential for compliance. Regarding the amperage, voltage, and other electrical considerations, the correct sizing and selection of surge protective devices is paramount. Firstly, the voltage rating, which must be suitable for the system voltage. For a standard 120 volts or 240 volt single-phase residential service, the SPD should have a voltage rating of at least 150 volts or 300 volts, respectively, to accommodate voltage fluctuations and transient overvoltages. Next is the surge current capacity, also known as the surge rating, indicates the maximum surge current the SPD can withstand without failure. For residential applications, a surge current capacity of 40 kA to 80 kA per mode, line to neutral, line to ground, is generally recommended. However, in areas with frequent lightning activity or a high risk of power surges, a higher surge current capacity may be necessary. Moreover, the type of SPD must be considered, such as Type 1, Type 2, or Type 3. Type 1 SPD are designed for installation at the service entrance and are suitable for high exposure locations. Type 2 SPD are installed downstream from the service entrance, such as at distribution panels or branch circuits. Type 3 SPD are point-of-use devices installed at individual outlets or equipment. In residential applications, a combination of Type 1 and Type 2 SPD is commonly used to provide comprehensive surge protection. Furthermore, the short-circuit current rating or SCCR of the SPD must be equal to or greater than the available fault current at the point of installation. This ensures that the SPD can safely withstand a short-circuit event without causing a fire or explosion. The SCCR is typically marked on the SPD nameplate. As it relates to the mode of protection, SPD can provide protection in different modes, such as line to neutral, line to ground, and line to line. Residential SPD should provide protection in all modes to effectively mitigate surge voltages. Also, the let-through voltage, also known as the voltage protection rating, indicates the maximum voltage that the SPD will allow to pass through to connected equipment during a surge event. A lower let-through voltage provides better protection. The let-through voltage should be as low as possible, typically less than 400 volts. Remember that the installation requirements are as important as the selection. SPD should be installed in accordance with manufacturer's instructions and applicable electrical codes. Proper grounding is essential for effective surge protection. The SPD should be connected to a dedicated grounding electrode conductor that is sized in accordance with NEC Table 250.66. Furthermore, the wire length between the SPD and the grounding electrode should be as short as possible to minimize impedance. Finally, regarding the environmental considerations, SPD should be installed in a location that is protected from moisture, dust, and extreme temperatures. If the SPD is installed outdoors, it should be housed in a weatherproof enclosure. Regular inspection and maintenance are essential for ensuring the continued effectiveness of surge protection. SPD should be inspected periodically for signs of damage or wear. If the SPD has a visual indicator, such as a light-emitting diode, it should be checked regularly to ensure that it is functioning properly. SPD should be replaced if they have been subjected to a significant surge event or if they are nearing the end of their service life.